Right, in the last video, we have installed the robots plugin. So you should have your robots tab at the top of Grasshopper. And in this video, we will be going over the most basic ways or the most simple ways of creating a robot program with this plugin. So we will add a load robot system component, and we will be using a Universal Robots UR5E for this video. Now, we want to define where this robot actually goes. So for that, we would need a point in space. And to do that, I will simply add a point by double-clicking the canvas and adding 300, 300, 300. And this will create a point param in Grasshopper. And if we select this param, we can also move it around in Grasshopper to change its location. Now, in order for the robot to know how to approach this point, we actually need more information. A point is just 3 dimensions, but our robot has 6 degrees of freedom, so we need more information for the robot to define this point in space. And for that, we will be using planes. And the robots plugin always uses planes as its input to a robot target or robot command. And the reason for that is that we don't just want to select a point in space, but we also need a specific rotation and direction from which the robot approaches this point. We can find all the components that we can use to create planes under the vector tab. And here we'll simply add an XY plane to my Grasshopper canvas. And you can see that there's now a plane preview in Grasshopper. And once we have that, we can actually add a robot target. So in the robots tab, find the create target component. And as you can see, it takes a plane as its input, and we can simply connect our plane to that component. And this is now enough information to create a robot program. So to create the robot program, I will add a create program component and add my target to the target's input. And I will add the robot system to the robot system input. You can see that there's still some warnings. And if we click on the yellow balloon at the top, we can see that there are warnings in the program. So we'll add a panel and preview these warnings. And what these warnings actually tell me is that there are some values that are not defined. So one target has the tool set to default, and the same target has the speed set to default, which is not an issue. We would have an issue if there were errors. So for example, if we have a point that is too far away from the robot, we would get an error. You can see the create program component turns red, and we get an error that says target out of reach. So as long as we don't have any errors in our program and the target is actually in reach, we are okay, and we actually created a valid robot program. We can also see that if we look at the code output of the create program component, and there we can see that it has a valid robot code. So in order to now actually have a preview of how the robot would move to get to this point, we need a preview component, and we can find this under the components tab and the program simulation component. And here we simply add our program output from our create program component to our program input for the program simulation. To see this a bit better, I will hide the load robot system. And here you can see that the robot actually moves and goes to this point, but it actually approaches this point from below. And the reason for that is because the z-axis of that point is pointing upwards, or sorry, of that plane is pointing upwards, which is always the case if we have an xy plane. So if we were if we wanted to have the robot move to this point from above, so to basically point downwards with its flange, we would need to flip that plane. And so we can go back to our vector tab. Under the plane components, we have a flip plane component. I will add this to the canvas and add it between our create target and our plane component. So after I flip this plane, you can see that the z-axis of this plane now points downwards. This was it before, and this is after flipping the plane. And now this flip plane can be used as our input to the create target component. And now you can see that the robot actually approaches this point from above. Of course, there's also situations where you actually want to approach a target from below, but it's really important for you to make sure that you know which direction your planes are pointing to make sure that the robot goes to that point from the right direction. All right. And this is already, basically a full valid robot program. We have robot code, we have a preview, and we could actually send this to the robot. Of course, this is not a very useful program, so we will add a few more components to make this a bit more interesting. If you've used robots before, you will know that there's a lot more that we can set in a robot target, which is usually called a waypoint. In the robot pendant, than simply its location. So we have a lot more parameters that we can set. And this is something that we can add to our create target component by right-clicking. And here you can see that there are more options. For example, we have a configuration input, which I will activate. And we also have a few more inputs that we can activate, such as a tool input, a speed input, zone input parameter, a command input, frame input, and an external input. However, I will only look at the configuration input right now. A 6-axis robot usually has more than one way of approaching any location. And this is what is called a configuration of the robot. So if I have the configuration checkboxes here, I can go through different configurations and basically change the way the robot approaches a point. This doesn't change the point at all. So this is still the same location that the robot goes to. However, the robot basically moves its joints in a different way to get to the same point. So this is also something that is quite important. Depending on where the point is, you will need to make sure that you have the right configuration of the robot, and also depending on what your tool is, or if you have cables running along the robot, you need to make sure that the robot is configured in such a way that you that there are no crashes and that the target can be reached safely. All right, to make this a bit more interesting, I will add a few more points. Usually you might have a curve or a 3D model that you want to segment in some way and get points and planes from that. But for now, I would simply copy and paste this point XY plane and flip plane component 3 times. And then I will use a merge component to create one list from these different planes. Of course, in Grasshopper, you can always add multiple inputs by holding Shift and adding them to the to an input. However, I would strongly discourage you from doing that, because when working with robots, it's always incredibly important that we know the order certain points are moved from and moved to. And so a merge component is super handy, because we can always see what our order of points is. And it's also much easier to disconnect something, or to change something, or to change the order. If I wanted to have the third point as my second input, I could simply switch this, and this would still be totally obvious. Whereas if we had multiple outputs going into one input, we could not see that. So I would encourage you to always use a merge component, especially when working with robots, but it's usually best practice to do even with other kinds of Grasshopper definitions. All right, because these points are all at the same location, this is not the most interesting robot motion right now. So I will simply click on a point and drag it to get to get 3 different locations. And now I can actually play back the robot motion by hitting the playback button on the program simulation component. And now if I click this, you can see that the robot moves from one point to the next. So it starts at the first point, goes to the second point, and then to the third point. I will quickly hide some previews here just to make this as clear as possible. And so we now have our robot program that moves between these 3 points. We can use this playback button to view the entire robot program. However, there's also a time input. So if I wanted to, I could add a number slider that goes from 0 to 1 and simply advance that number slider to look at where the robot is at a certain location in its program. So at 65% of the robot program, the robot is at this location. One thing that is important, if you want to use the playback button, you will need to have the number slider set to 0. So if you try to playback your robot program and the number slider is at 1, this won't work. So if you want to use the playback option, always make sure that your number slider is at 0, because the playback will always start at the position that you set with the number slider. So a quick recap. We loaded our robot system and we created 3 points. From these points, we created planes. We flipped these planes to make sure that the robot approaches them from the right direction. We wanted the robot to approach them from above. So we flipped them around to make sure that their z-axis is pointing downwards. Then we merged them together to into one list. And that list is now our input to our create target component. We can toggle different options and different parameters on the create target component, which I will go over in a following video. But for now, we have our configuration input that we can use to change the configuration of the robot to make sure that the robot is configured in such a way that it can reach the points, but also doesn't hit anything, such as maybe a table that it's attached to. We then use the create program component and input the robot system as well as the target list, and then have a simulation component that allows us to preview the robot motion exactly as the robot will do it. In the next video, I will be going over how we can send this program to a robot, to a real robot, or to a UR sim. And we will also be going over how to make more adjustments to the create target component and add a few more things to our robot program that make it more interesting and closer to something that you would actually use in the real world.